Hey everybody, this is Sam with Nexus Workshop, and we are going to be looking at the Nexus Ultimate Prop Controller. Specifically, we're going to be looking at a couple games we can play with some analog inputs. So we already have a little video that's taken us through a couple different button inputs. Those are things that go digital. They are true, false, on, off, pushed, not. Now we're going to go into some analog inputs, which is something that the prop controller tends to call level inputs. Those are things that can vary all the way from 0 to something. In this case, it goes from 0 to 4095 because it's a 16-bit reader on there. On my prop controller, I've got a picture of it down here. I've got my main controller here, and so this, just like the last one, is powered with PoE. So I've got my network cable here, which is bringing in my network connection as well as my power. Now, I could run this off Wi-Fi, but the Ethernet's going to give me a little bit better reliability, and I can power it over the single cable, which is nice and easy. I've got my buttons from the last video. We're not going to use this in this one. Instead, over here, I've got my power rail, where I've got all of my 5-volt and ground connections. So you can see I've got my 5-volt and ground coming actually from my board to my rail. And then I've got my ones from here feeding my relay, powering that, powering my little pixel strip here, and then also giving me my power and my ground on my two analog sensors here, which are my potentiometers. They're my little analog pot, my knobs. Could be knobs, could be faders, could be little flex sensors. There's a whole lot of different things that can work this way. Another thing that's cool about the analog inputs or level inputs is that it doesn't have to just be a potentiometer. It doesn't have to just be a resistor. We can also use the level inputs concept for things like color sensors that are connected over I2C to our board. There we get a color value from a number to a number, and we can use the same sort of mapping to define our ranges or our map for those, which can be very neat. Again, the way this works here with these analog sensors is I've got this signal wire, and this is ultimately a resistor that's creating a little voltage divider between my voltage rail and my ground rail. And as it's adjusting, it's choosing how high to take into that signal. So that signal is going from 0 to 5 volts, and then the controller itself reads that and decides what does that mean? What is that level between 0 and 5? Now, important distinction is this is a 3.3 volt logic controller, which means it's actually ranking from 0 being no voltage all the way up to 3.3 being 4095, the highest level. Because we have 5 volt connected up to it through these resistors right now, that means that it's actually going to hit 3.3 and then the voltage is going to keep going on my knob. But my reader, my controller is actually going to top out there. That means that these knobs are actually going to bottom out a little bit early on me. That's part of how I have it set up on this little test board. It doesn't have to be that way. If I really wanted to set this up in a prop, I would be connecting these, instead of 5 volt here, I would connect this into a 3.3 volt line, either from my regulator or from the board itself, and that would help these actually register their entire range. For me, on this little test board, it was a little easier for today just to set it up to 5 volt, and we're just going to deal with that as we do our mapping. Again, the downside is that I don't get all of my range of motion. Some of it just kind of tops out and then keeps going. Not a big deal for right now. So let's take a look at how this looks in the controller. Here I've got my initial setup. I've just wiped this board so it is factory reset. I'm going to give it a name. I'm going to call it analog prop. And hit continue. It's not going to ask me about my network because I am plugged in with Ethernet, like I said. So it has network already, so it doesn't care about that. I'm going to skip the admin password because I don't need it right now. That'd be a really good idea to set your admin password once you finish your config. That way you're not having to enter it every time you go into the config window, going back and forth as you're testing things. But you definitely do want to have that set up if you're in any sort of situation where people who shouldn't be making changes could accidentally make changes. Again, that's not really your security per se. Your security is the fact that this is on your network and your network should be secure. This is more just accidental people who are on your network, your employees, your game masters, things like that, accidentally getting in there and messing with something that they don't mean to. Here, I am going to skip the prop wizard and I'm going to go manual setup, and we're going to take a look through this. So the first game we're going to build is going to be taking those two knobs and saying when the knobs are set to the correct position, it solves. And it's going to trigger my relay and it's going to turn my light on. That's going to be pretty easy to set up. First thing we're going to do is add all of our inputs. So I come here on the connections page and I go to inputs, outputs, and modules and add device. Now I'm going to check this little box, which is going to let me add multiple without closing down, so I can add them all. And I'm going to add 2 analog sensors, a relay, and a set of pixels. That's what I've got here on my board. Go ahead and hit close. And now I need to go ahead and set the pins because I already have them wired up, so I need to set the pins that I connect them to. The other way to do this, and what you'll probably do most of the time, is by adding your things and then taking its suggestions and building your board based on that. For me, I know that this first one I'm going to call knob 1, and that is going to be on L15. This one is knob 2. I have that already connected to L16. This one I'm going to call relay, and that is connected to L9, and my pixels are connected to L10. Now I have everything named and my pins selected. I can come up here and click Apply I/O Changes. This is one of the only sections on the board that I do have to manually save to make sure that it gets all the pins applied, initialized in the right order, all those things. But as soon as I hit Apply, it automatically has saved, rebooted the board, and refreshed the page for me. I'm good to go. Now, because I have pixels, I'm going to come over here to lighting, and I'm going to really quickly change this, because by default, whenever I add pixels, it makes a string of 20. I don't have 20, I have 8. I'm going to save that. This is one of the only other sections that I have to manually save. And now I'm going to start going through my actual setup. So for this prop, I'm going to have 2 states. I'm going to have one called armed, and I'm going to copy that, and I'm going to name this one solved. Don't have to do this based off states, but I like to. It keeps me nice and organized into what I'm doing. So I created my 2 states there. I'm now going to come down here into level inputs, and I'm going to go add level input. A level input is a definition of either a mapping or specific sort of slots along that. So like I said, these knobs are going to read between 0 and 4095, but I don't want to be dealing with, okay, am I exactly that number? I want to say, well, from here to here is good. And so what we're going to do is we're going to come in here. This level input is using input 1, is knob 1. Its mode is going to be range. And then I'm going to create 4 ranges here. And I'm going to call them down, 12 o'clock, 3 o'clock, and up. Those are the 4 positions that I'm going to care about on here. And now I'm going to define where they are. So my knob 1, I've got it turned all the way down, and you can see up here that it's reading. So there's my 4095. You'll notice that, again, like I said, like that one stays pinned pretty well because it's all like 3.3 volt all the way up to 5 volt is reading at that max. But as I start to turn it down, you can see it start to move around a whole lot here. And you can see how much it's kind of varying and bouncing around. And that's why these ranges are going to be really good for us. So I'm going to come all the way up, and I'm going to, actually on this first one, I'm just going to do 4095 and 4094. Just saying like, yeah, if I'm pinned to the top, that's all the way down, because that's turning my knob to the left. Whether that goes from 0 to 4095 or 4095 to 0 depends on how you wired your pot, but you can kind of just wire it up and then come in here and configure it how it is, no problem. So my 12 o'clock position, what I'm going to do is I'm going to go all the way up to 12, and I'm going to go just a little bit to one direction, and I'm going to learn that. I'm going to go a little bit to the other direction, and I'm going to learn that. Oh, I clicked it on the wrong one. Let's do that here. There we go. And then let me put these back. No, there we go. Now you'll also notice that I don't have to, min and max doesn't have to be a lower number and a higher number. It's just 2 numbers that are bookending this position that it'll accept as this thing. I'm now going to go to 3 o'clock. I'm going to go slightly above 3 and click that, slightly below 3 and click that. And then I'm going to go kind of all the way up and then turn it down a little bit. Let's go a little wider. There we go. So now I've got my ranges there. I'm going to go ahead and copy this and duplicate it for the second one. So now I've got this for knob 2. I'm going to apply it to knob 2. And then I'm going to come in here, and I actually do want to go ahead and set my ranges again, because no 2 pots are the same. Sometimes they're really close. Sometimes they start to differ a little bit more. But the easiest thing to do, since I can just clearly come in here and define them all, is to just set it again for this pot. So I'm going to go, my down is going to be the same. That's my max. I'm going to go do this 12 o'clock. So just a little shy of 12 o'clock, learn that. A little past it, learn that. And we can already see how far off that's gotten compared to the other one. Here we go for 3 o'clock, learn it, and then my minimum, learn it. Ooh, learn it. There we go. Something like that. So now I've got my ranges. I'm coming in here and I've defined the different parts on these knobs that are going to go. Now let's come over here to behavior, and we're going to start actually building this thing. So the way we're going to build this is we're going to be looking and we're saying when knob 1 is at 12 o'clock, knob 2 is at 3 o'clock, and we're armed, then you're allowed to solve. When both of them are all the way down and we're solved, then you should reset. That's our two logic rules that are going to drive this. And they are logic rules because each of those listed out multiple conditions that all need to be true. A logic rule is how we're going to do that because it lets us set up multiple conditions and check when all of them are true. So my first one is going to be called solve. It is a match all because all of these things need to be true. My state needs to be armed. Great, that was the default. I'm going to come here, create a new condition, and go analog, knob 1 is 12 o'clock, and analog, knob 2 is 3 o'clock. When we're armed, 12 o'clock and 3 o'clock, then it fires the solve command. Now remember, logic rules don't do anything. They just fire. I'm going to have to create an action trigger that says, okay, when that logic fires, here's all the things you do. The reason for that is because we're going to end up doing multiple things, and we'll get to that in just a moment. The next thing I'm going to do is actually not here. Let me delete this one. I'm going to duplicate this rule, and I'm going to call it reset. And then it is going to go when the state is solved, and both knobs are all the way down. There we go. So I have my two logic rules, the two things that say when all these are met, do this. When all these are met, do that. Now I need to decide what is the do part of that. And that's going to be action triggers. When this happens, do that. So let's create an action trigger, and we're going to call it when solved. It's going to fire based off a logic rule of solve. So when the solve logic rule fires, then this is going to go. And what's it going to do? It's going to take my relay output. It's going to turn it on. It's going to take my pixel lighting, and it's going to light it up green. And then it's going to set my state to solved. So it does those three things. It's going to do them all at once, and it's going to go relay, light, set the puzzle to solved. That's what happens when the solve trigger goes. I'm going to duplicate that. I'm going to call this when reset. It's going to fire on the logic rule reset, and then it's going to do the opposite. So the relay turns off. The light effect, instead of starting, stops. So it stops whatever's running on that pin, and then we're going to set state back to armed. There we go. Now I'm going to come up here. I'm going to go back to operator. And here, it's going to let us run our thing. Now, it's giving me a warning saying, hey, there's an action precompile that's out of date. I'm just going to click OK. That has to do with it like pre-caching the different directions and things that it can go to. And it does that so that it can work in runtime really fast. Whenever it brings that up, you can just click OK, tell it it's OK to run it. Usually, unless you've built out a lot of pixel stuff, it's going to be instant. But if you do have a lot of things, especially that precompile is going to come in handy, it'll run pretty fast. It just wants to warn you so that it doesn't run while the game is going. So we can see right now my knobs going crazy. They're both reading really, really fast. And we can go ahead and run our thing. So over here on our logic rules, we can see that we are in the armed state. So since we're armed, we're going to go ahead and turn my knobs to 12 o'clock. And I can see that that one went to 12 o'clock. And then my other one's going to go to 3 o'clock. And boom, that solved me. I come down here. My relay is tripped. My light is green because I'm at 12 and 3. The next thing, if I turn these all the way down, then it resets me. And that's as easy as that. We have our two logic rules that drive us into my puzzle solve, into my stop. Some other things while I'm here on the relay page that I can show you is I do have some overrides for, like, for instance, I can click on my output and I can toggle it. So that turned it on, that turned it off. I can also set it to a specific state, or I can flash it. I can also do that for any other outputs. I can choose my state and manually drive it up here. And I also can override these logic rules and just say, you know what, that fired. So let's go ahead and do our next little game here. The next one is actually less of a game, more of just a feedback piece. But what we're going to do is we're going to take that knob 1 and we're going to make it drive a meter on those LEDs, which is a really fun trick that I like a lot. So to do that, we're going to come in here to my config. I'm going to go to definitions and create a variable. I'm going to call this variable meter value. It can say as a string. I don't need a startup level. I just need to put that because that's how I'm going to handle my mapping. I'm going to come down here to level inputs and I'm going to add a new one. I can have multiple level inputs for each knob that do different things. This one is going to also look at knob 1, but it's going to be a mode map. And I'm going to go ahead and call this meter. Down here, its target is going to target that variable that I just created, the meter value. There are other things it can target, but mostly it's the variables. So since I have that created, it selected that automatically for me. I'm going to map all the way from 0 to 4095, and then I'm going to actually map this backwards, because I know it goes backwards, from 100 to 0. So basically what I'm taking is I'm taking that number, flipping it around, and I'm making it give me the percentage of how much is this knob turned up. That's all I need to do here. Now I'm going to come over here to behavior, and I'm going to create a new action trigger, and I'm going to call it meter. The trigger type is going to be based on that variable changing. So variable meter value on change. Every time that value changes, reevaluate and see what we need to do. And the action is going to be a pixel meter. Now in pixel meter, I have a bunch of settings that I need to set. The ones I'm going to do is I'm going to say the source of this meter drive is that variable. So meter value is what's driving this output. And remember that I already set that up to be from 0 to 100%. Now I'm going to come in here and I'm going to say I want it to be gradient. What that does is it decides if it's going to like step up each pixel or whether it'll allow pixels to be faded. I'm going to set both of my modes to be chase, on and off, because I really like it. I think it looks cool. And I'm going to say that when it's off, I'm going to go with a dark blue with a minimum of 100. And when it is on, I'm going to go with a yellow with a minimum also of 100. That's all I need to set up here. And then now I'm going to come here and show you this. So now if I move this knob, it is going to start bringing up those meters across that. And you can see it's got this really cool like chasing wavy effect that I like a lot. Now one thing is I noticed that as I'm going up and down, it's lighting more pixels as I turn up, which is good, but it's writing them from right to left. I want to go from left to right. So the way I'm going to change that is I'm going to come here and go reverse, turn that true, and come back over. And now, let's see. Did it flip me? It doesn't seem like it flipped me. Let me reload that and make sure it's stuck. It didn't. There we go. I just set it back to true, and there we go. So now, as I'm turning up and down, we get it going the right direction. So now we're going to do one more little game here. This one we're going to do is going to be kind of like a collection game. And I actually shouldn't call it that because collections is a whole type of game that we have built here, and we're not actually going to use that. Instead, what we're going to use is the ordered sequence, the input sequence option, but we're going to collect these different states along the knob. So what's going to happen is we're going to say the knob has to go all the way up first, and then it's going to go to 12 o'clock, 3 o'clock, 12 o'clock, and that's going to be our code, those 4 positions. The way we're going to do that is over here on the input sequences. I'm going to add an ordered sequence. I'm going to call this one, let's call it knob positions. And its mode is going to be allow misfires. Now that's because normally if I had like a button game, like we did in the first one where I pushed the buttons 1, then 2, then 1, then 3, that's fine. But here with the knob, I can't avoid going back through them. So if I do what I just did, I go up 12, well, I had to go past 3 o'clock to do that. Normally, that would have gone into my code and would have broken the code. I wouldn't be able to complete it. So allow misfires says, hey, I don't care what you do in between. You have to go hit all of these steps in order, and you have to do it before the timer runs out. So when I do the first one, it'll start the time, and then the other ones go in order, and that's how I complete this game. I'm going to only allow it to work in the armed state, and then I'm going to add my mappings. So my mappings are going to be of the type analog. It's going to look at knob 1, and we're going to go value up. Now let's clone this out a couple times. because my three things I care about is value up, 12, and 3. Those are all these analogs on knob 1. I care about up, 12, and 3. And I'm going to go ahead and just call those 1, 2, 3. And then my code is going to be up, 12, 3, 12. So 1, 2, 3, 2. That's my code. All right, now I've taken those different knob positions, or those full ranges, and I've said this is the order they have to go in. Now I need to actually make my thing do something. So I have my input sequence here. I'm going to come into action triggers, and this when solved, instead of solving it off my old logic rule, instead I'm going to solve it off of that. So I go sequence, it already has knob positions, and instead of every change of the knob positions, I'm going to trigger it on success. So let's take a look at what happens. I'm going to come in here. So if you watch down here, you can see the input sequences. You can see that my code is 1, 2, 3, 2. And if I go and turn it all the way up, there's 1. I turn it to 12, 2, 3, and then back down to 12. And that was my solve. If you want to see it again down here, to reset, remember, I go both knobs all the way down, and here's my reset. And then I can turn this up. There's my meter. I go all the way up. I go to 12 o'clock, to 3 o'clock, to 12 o'clock, and that's my solve. Now, one thing that we notice was that the meter is actually overriding my solve on those lights. The way I'm going to fix that is I'm going to come in here to my config, and I'm going to come in here, and I'm going to look back at that meter lighting, and I'm going to say that it can only work in the armed state. That way, as we transition into that solved, that's when the light goes green, and that way the meter's not going to step back on top of it. Let's take another look at this real quick. So we go reset, and I go turn it up, 12 o'clock, 3 o'clock, 12 o'clock. One of the things you may have noticed was that the meter lights were actually able to step on top of our green lights. So what happened was our puzzle solves really quick, it goes green, and then the meter lights, because that fader value is changing, immediately steps on it. So what we're going to do to get rid of that is we're going to come over here to our config. I'm going to go into the meter action trigger, and I'm going to make it only work in the armed state. So that way it's not going to be firing anymore when we're solved, because we should be green at that point. The other thing I'm going to do is I'm going to come in here to this when solved, and I'm just going to add just a little bit of delay to that green so that it happens right after we get in there, making sure that we're fully in the solved state and that it's the last one to trigger. Now let's come back over here, and we can go ahead and show you my camera. So I go all the way up. I go to 12, 3, 12, and there we go.